So I welcome you again, everybody who's watching this video, to a video about dot product and vectors. We're going to be a little bit transitioning from paper and what we have on our vyPython to get this vector to be, it's going to be a little bit confusing, but we're going to try to see and get what we want from dot product and vyPython. So I first want to go ahead and do that before we get to any of the marks. We have to find out that if you have a dot product and we have the magnitude of our angles, how we can get an angle to find out, okay, what was the angle between these two angles just from our dot product formula. So what we're gonna do is we're gonna, hey, first, just like how it's been said in chemistry and physics, or even in algebra, let's say if the angle even if it's x, what you would do in an algebra, you would get the x isolated. So that's what we're going to do. You're going to isolate the angle of A and B, since we have vector A and vector B on our question. You're going to get that angle isolated, and then find out from numbers what to do. So you have the dot product of those two vectors over the magnitude of those two angles, magnitude of A times vector, magnitude of vector B. For now, we have only vector on this question, and then you have cosine of AB. And now, what we can do to get rid of the cosine? We go to our cosine of the whole thing on the other side, the dot product of the vectors, and the magnitudes of vectors being multiplied to each other. So now we're going to go to vyPython and see how we can do this in vyPython, and then come back to see to pretty much get our stuff around. So I see you guys in minutes in vyPython. I welcome you back again to vyPython, which is a very good app that we use. I already run the code. As you see, I have also the code over there as a cosine of whatever we got in paper, and I plug it in. So because of the codes that my professor gave, and then I use that degree, I'm getting a vector A, which is the magnitude is 4.58. Now I could have printed the magnitude of vector B. That would have been fun, but let's get to more important stuff before I actually run outside of time. Vector A and vector dot vector B is going to give a -3. Now looking at what the angle is giving me is 112.208, 112. It has an obtuse angle. So this is supposed to be actually correct, because when we use this dot product of negative, it has to be obtuse angle, because obtuse angles dot product is going to be negative. Now we're going to check other angles to see like what they're going to do. And I use a protractor to find out what it is, and I have my own one. I couldn't find a Google one, unfortunately, so I put it right next to it to see whether this is going to be the same angle. And I get close to 112, so this is actually, yes, it's a 112 degrees angle. That's what my protractor shows. So now we can find out that yes, this is the right angle, and this is a right number that we are getting, a scalar. On paper, we did vector A and vector B, the dot product, and then we had the magnitude and the cosine. So we're going to put this in an equal. We got a -3 for dot product, and then we have 4.58. Now I realize I should have put a code for vector B, which I did. I'm going to show you when we back to vyPython again. I'm going to get 1.73 as a magnitude of vector B, and then cosine of the angle that has been given. I will support us with the protractor at the code. So we get the cosine of 112.208, and then we're going to put them equal to each other. Now you want to see if we would get a -3 dot product just by doing this in a calculator. And I did that, and I found out 2.99, which is literally is -3. So you get -3 as a dot product, so that means it's correct. Yes, this dot product is correct. We checked the code, and this is right. So now we're going to do two other angles, and let's see how they will look like on a vyPython. Alrighty, so we get back to vyPython. I missed the vector A, and as you can see, I print vector B's magnitude to get 1.73. And now we change vector A though to 0.222, so get 2.82, and we get the angle between them as 90. Remember, 90 degrees angle, we're going to get dot product of 0, which I also checked the protractor. The angle is 90. Show me that the angle is 90 degrees. So we have a 0 dot product, which is mean when you have a right triangle, you're going to get 0. Now I'm going to go ahead and change this code a little bit, because I know if I change this to 1, I should get an acute now. Acute angle. Yep. So if we get a acute angle, I still miss with vector A, the red one, and I get a 75.0368, which is a very acute angle. I should get a positive, which is yes, which is 1. Now let me check with the protect. Okay. Oh, sorry. Yeah, I get 90, 0, and then I have an acute angle now, which I get 75, and I should get a positive one, which I get. Now let me check the protractor where that is right. No, that's not 90. Let me put it exactly here. And absolutely yes, I get a 75 degrees angle, which that means that is correct. And this is the acute angle. Yeah, I get 75 degrees with the protractor, so that seems to be absolutely right. And this is how we get acute angle, positive, opposite, obtuse, negative, and then right angle, 0. So that's how we change. So hopefully you guys enjoyed something new, and I see you guys in next videos. I'm gonna put it right next to here. I'm gonna move this. Oh my god, okay. Excuse me 1 minute. This is a little bit hard to write with one hand. Okay. And see if you can get other dot products that we actually need. So I see you guys in doing the rough paper again, this dot product.